Trigonometry, section 7.1, the law of sines, page 338. Okay, so far we have dealt with right triangles the whole way, haven't we? And that, we can do a lot with right triangles. We can do a lot of things with right triangles because our world has a lot of right angles. However, it doesn't always work out that we can get a right triangle. So we have to have some other ideas that will help us to solve things that are unknown. Okay? And this is where the law of sines and the law of cosines come in. Okay? Now, first of all, there's a table on page 338, and that table is a wonderful table because it gives you an idea of what happens. You're going to have a flashback to geometry a little bit. The first is we have an AAA case. All right? Now, that's if I give you all three angles of a triangle, and what can you find? And the answer is you can find absolutely nothing given all three angles. Okay? None. There are no triangles that are formed that we can identify. Obviously, you can have a triangle, but you don't know how to find any of the sides or anything. Okay. So the next three, the next two we're going to study. I'm not sure that we'll get to the third case. We'll see how time permits us. The next two are the AAS situation, which stands for angle, angle, side. Now notice the side is opposite one of the angles. Do you remember from geometry that the side is opposite one of the angles, okay? It's not between the two angles, correct? Otherwise it'd be ASA, right? Well, speaking of that, we do have ASA, and here is the side is between two angles. Okay? And then the third one, I'm going to go ahead and write it down in case we get to it, but it's called the SSA. Now, I always say if it can create a bad word, it's trouble, right? And this one, if you're dyslexic, you know what I'm talking about. All right, but this one is also, this one has two sides. So it's different than the other two. The other two have two angles. This one has two sides. So if you're given two sides and an angle, not between those two, right? Not between those two. Okay, this is the bad case, and this is also a law of sines, but this is what we call, I got to spell this right, the ambiguous case. So the ambiguous case means this, that you can have no triangle, you can have one triangle, or you can have two triangles. You don't really know, so you have to plan for each, okay? And there's a way to do that. So if we get time, we'll talk about the ambiguous case, but if not, we're going to focus on the top two, and this is the law of sines. The law of the sines takes care of these cases. All right. Now, there are two other cases that we're going to get to. It's the SAS and the SSS. Notice that the angle is the included angle. What does that mean? It's in between sides, and then this is all three sides, and these are the law of cosines. Okay? And today we're going to talk about the law of sines. So we're not going to deal with the law of cosines today, but it is just as valuable. All right. Well, first of all, you have to memorize the law of sines, and I'll give it to you. There is two forms of it. The first form that I use, and actually the book lists it second, is A over the sine of angle A equals B over the sine of angle B equals C over the sine of angle C. Notice the lowercase letters are the sides, and the uppercase letters are the angles. And I can use this part of the proportion, I can use this part of the proportion, or I can use these two on the outside. Okay, I can put any kind of proportion I want. This is called an extended proportion, but we're only going to use part of it, right? Now, the book refers to it, flipping it over. I mean, in other words, you could take the sine of A over A equals the sine of B over B equals the sine of C over C. You can do that however you want to do it. I prefer this way, so that's the way I do it. But either way, you'll both get the same answer, correct? All right. So let's take, for instance, so we're gonna deal with these two today. Two angles and a side. It just kind of depends on where the side is, correct? All right. Well, let's start with number one. In a triangle, ABC, angle A equals 30 degrees, B equals 70 degrees, and little a equals 8.0 centimeters. Now, given that answer, how many decimals? Okay, yeah, we need to go 2 significant digits, correct? So probably to the nearest tenth, right?
Yeah.
We want to find side C. Okay? Find side C. All right. Well, I want you to look at this. We are given angle A and side A. In other words, we have one across from each other, right?
Mm-hmm.
All right, so the first thing I need to do is probably draw it. And I don't care how you draw it. I just draw a triangle label ABC. I don't really try to get the angles close to what they are. Otherwise, I'd spend all day doing it. And then I just label it. This is 30 degrees. This is 70 degrees. And little a is 8.0. Now, please don't come to me for help without a drawing. Okay, that just then we have to spend the first 5 minutes waiting for you to draw it. So have it drawn if you have questions. Okay, so we're going to use the formula. We're going to start. It doesn't matter. I'm going to start with 8 over the sine of A, which is the sine of 30 degrees, correct? Equals, and then I have B, but they want to find little c, right?
Mm-hmm.
All right. So I need little c, and that's x, right? Maybe I'll put c there so you know that's c. But what goes down here? The sine of angle C. And how big is C? 80 degrees, correct? Because they add up to 180, correct?
Yeah.
Now listen, normally I wouldn't tell you to use a value that you found. But on these you have to, a lot of times. Try not to, but in this case you have no choice. The odds of you missing sine of 80 degrees with the calculator is pretty tough. All right. Now I just cross multiply. So I take 8 times the sine of 80 degrees equals c times the sine of 30 degrees. Correct?
Mm-hmm.
Then I divide both sides by the sine of 30 degrees. And I get c equals 8 sine of 80 degrees all over the sine of 30 degrees. Okay? Now when you do this, try to put it all in your calculator at once so that we're not rounding values. You understand what I'm saying? We're not rounding values too soon. So c to the nearest, well, 2 significant digits is what?
So 2 6
Mhm.
16.
16. Do you understand that?
Yeah.
16 centimeters. Okay? Questions? All right. Let's take a look at another type of problem. This will be number 2, example 2. It says, find the missing parts. Now that's going to be more than one answer, right?
Yeah.
Of triangle. They like to use ABC quite a bit, so we'll stick with it, ABC. If B, which is an angle, notice they don't use an angle symbol, right? they just use a capital letter. C equals 82 degrees, and A equals 5.6 centimeters. Okay? Now you'll notice that we have two angles also. Like the last problem, only we have a side that what is across from, 5.6, I forgot to write that down, A equals 5.6, so we have an angle in between them, correct? Or excuse me, we have a side that's across from. So I'm going to go ahead and draw the triangle. Once again, I just draw a triangle, A, B, C. Little a is 5.6, so across from that. B is 34 degrees, and C is 82 degrees, right? Now we have to find all the missing parts, right? Okay, let's start with angle A. How big is that?
64.
64. Okay. Now we know angle A, so we can use it, and you gotta always have that side that's across from the angle to use, right? So I'm going to start with 5.6 over the sine of 64. Don't forget to take the sine of it. Equals, I'm going to start with B. So I'm going to go little b over the sine of 34 degrees, correct? Okay. Is that true? All right, now I'm going to show you a quick way to do this. I'm just going to multiply this up and over that. So it's just going to be 5.6 times the sine of 34 degrees over the sine of 64 degrees. And that equals b. So b equals 2 sig figs.
3.5.
3.5.
Yeah.
Did you get that, Josie?
Not yet.
Okay.
Yep.
Okay. Now you might have made a mistake on 3.5 centimeters. You can use 34, the sine of 34 degrees, and 3.5, but I would go back to A and use A again, because you know that your odds of missing that one are pretty slim, right? So you would say 5.6 over the sine of 64 degrees equals C over the sine of 82 degrees. So it's going to be basically the same problem, only a little different numbers, right? So you're going to have 5.6 times the sine of 82 degrees over the sine of 64 degrees, and to 2 sig figs.
6.2.
6.2,
Yep.
and that is centimeters, correct? Josie, did you get that?
Yep.
All right. Now, I'm going to give your assignment, then we're going to look at a couple, or maybe one. I don't know how much time we have. But we're on page 345, so page 345. We're going to do 1 through 15, 20, 21, and 26. Okay? I think 1 through 15 are pretty self-explanatory. Okay? In fact, the first 10, you're just finding a value, and then the next 5, you're finding all the parts. Okay? So just like we did. But let's take a look at 21. Okay? Can I throw out B or 20?
Yeah.
Would you erase that? Okay, for right now. Let's take a look at 21. Once again, drawing it is big. Okay, one of the things I want to point out to you is that r is the radius of the circle. It says in the directions in figure 12, the radius r and center c. The distance from A to B is x. So from A to B, this little piece right here is x. The distance from A to D is y, so that's y. And the length of arc BD is s, so this is s. Okay, that's an arc. For problems 21 through 24. Okay, so I'm going to get you started. I'm not going to complete all of it. I might add 22 to it. We'll see how it goes. But A is 31 degrees in this case. Okay, 31 degrees. This is 11. Okay. And it says the length of arc BD equals 11, right? And then R is 12, correct? So the radius is 12, and we want to find x. Okay, we want to find x. We do not have a right triangle, correct? No. All right, so they gave us S. Do you guys remember a formula that said S equals R theta? Okay, just keep that in mind, okay? Theta has to be in radians. I don't know if we're going to use that or not, but let's keep that in mind, okay? So x is, we have the side, this side, right, opposite that. So we do have an angle and the length across from it. So we could say that 12 over the sine of 31 degrees. And the question is how big is x, okay? Well, this whole thing is x, right? And we know this is 12, right?
Yeah.
So we could go, what, x plus 12
Yep.
over, and we need to find this angle right here, correct?
Yeah.
Okay, so we don't know that angle, do we?
Right.
Do we know this angle? All right. Well, we do. We can use this formula to say 11 equals the radius, which is 12 times theta, right?
Yeah.
Okay, so theta equals 11 twelfths, correct?
Yeah.
Now that's in radians, right? We need degrees, correct? So how many degrees is that? How would I find that? I would take 11 over 12 times what? It would take what? 180 over pi. Okay. Okay, would you do that on your calculator and give me to the nearest? Looks like we better just take it to the nearest whole number.
You got 165. I got 52.
Try it again. 180 times 11 divided by 12 times pi. You're dividing by both of them. What'd you get? 52 degrees? All right, 52 degrees. All right, so that's that angle. We want this angle. So what would be that angle? Angle D.
97.
So the sine of 97 degrees, correct? All right, so we have 12 times the sine of 97 degrees equals the sine of 31 degrees times x plus 12. Is that correct?
Yeah.
So we're going to divide both sides by this. Okay. And so I'm going to have 12 times the sine of 97 degrees over the sine of 31 degrees. And then that equals x plus 12. So if we subtract 12, that'll give us x, won't it? You have to do this in parentheses first before you subtract 12. Okay? That makes sense? All right. All right. Would you do that for me, please? And tell me what you get.
I got 11.
Yeah, 11. Now, I did most of that problem for you, so I'm gonna add on 22, okay? Add on 22 so you can do one like that, all right? So instead of doing 20, we're gonna do 21, 22, and 26. And this is due Monday.